Today's video is on lessons 10 and 11 from Unit 6. Lesson 10 is pretty much a review from geometry, and it is all about the equation of a circle. So you really need to remember what the equation of a circle looks like, and you need to know two things to write the equation of a circle. You need to know the center, and then you need to know how big it is, so you need to know the radius. The center coordinates go in here into the equation as h and k, and then the radius goes on the other side of the equal sign and you square it. Now notice the equation is always x minus your x coordinate of your center and y minus. So that means if the coordinate is negative, when you plug in a negative, that's really a positive. So you just got to kind of remember the trick that the signs of the coordinate look like they're opposite of what they really are when they get plugged into the equation. So for example, in this first one, while this looks like the coordinates would be -2 and -7, it's really +2, +7 because of the way the equation is set up. It's always x minus whatever the x coordinate is. So the x coordinate is actually at 2. And then the y coordinate is actually at +7. So if you can just kind of remember the trick that the signs are opposite of what it looks like they are, then that'll help you. So the center in A is actually at +2, +7. And then to get the radius, so if you look back at the equation of a circle, it's equal to the radius squared. So what that means is this is equal to whatever the radius is squared. Well, sometimes they're really easy to do in your head, especially if they're perfect squares. What number squared is 100? Oh, it's 10. So the radius is 10, otherwise known as the square root of 100. Now, if they are not perfect squares, you're just going to leave them in radical form. The first couple, though, are perfect squares. So letter B, the center would be at +5, -8, because really this plus sign came from it being a minus a -8. And then the radius is the square root of 4, which is a perfect square, so I can rewrite that as 2. In this one, you're probably thinking, wait, there is no parentheses and there are no numbers. Well, technically, this can be thought of as x minus 0 squared, and y minus 0 squared equals 121. So if there is no number and no parentheses with either variable, technically it's 0. So the center for this one is at 0, 0. The radius is the square root because it's equal to r squared. So to unsquare, you square root 121, which is 11. The next one, so I'm just going to kind of go through these a little quicker. The center would be at -1, -2. The radius would be the square root of 1, which is 1. The center here would be 0, +3. The radius would be the square root of 49, which is 7. The center here would be at -6, +5. The radius would be the square root of 18, which is not a nice number. It's not perfect, so just leave it as radical 18. The next one, the center would be at 0, 0, and the radius would be the square root of 64, which is a perfect square. It's 8. The next one, the center would be at 4, 2, and the radius would be the square root of 20. And the last one, the center again is at 0, 0. The radius is the square root of 57, which is not perfect, so you're going to leave it as the square root of 57. Now, the next and last exercise, this puts together what we did in lesson 8 with circles, which was completing the square. You need to take this form of the equation of a circle and turn it into this form. So what you want to do is you're going to do completing the square twice. First, you're going to complete the square with the x's. You're going to turn it into a perfect square trinomial so that you can rewrite it like this. Then you're going to complete the square with the y's, so you can write it as a perfect square trinomial in factored form. And then you're going to clean it up and tell me the radius and the center. So even though we're completing the square twice, we're going to do it all in one step. So first thing you have to do, if necessary, is to rewrite these terms, like reorder them, so that the x's are together and then the y's, but they already are. You also may need to move the number that doesn't have a variable to the other side, but it already is. So now I'm going to start my completing the square process. First, check to make sure there's no number in front of the x squared or the y squared. If there is, you have to divide it out. I'm going to leave a blank because I'm going to complete the square with the x's, then I'm going to complete the square with the y's, and then on the other side, whatever I add to the left side, I have to add on to the right side as well. So I'm going to put 2 blanks over there. So remember, to complete the square, you take half of 10, which is 5, and you square it. That's 25. Half of -2 is -1, squared is 1. So I have to add 25 and 1 to this side. Now, the whole point of completing the square is that you just turned these 2 trinomials, one is with x and one is with y, into perfect square trinomials, which means when you factor these, you will get 2 factors that are exactly the same, which means you can rewrite it as a single parentheses squared. So for example, you don't have to do this in the future, but I'm just going to show you where this comes from. This factors to be x plus 5 times x plus 5. Notice it's exactly the same. The two factors are exactly the same. So I can rewrite that as x plus 5 squared. Well, now you'll notice this looks a whole lot like the first part of the equation of a circle. Now you're going to do the same thing with the y's. This would factor to y minus 1 times y minus 1. Well, that's otherwise known as y minus 1 squared. And then on the other side, if you add all of these up, so 25, 35, 36. Now this looks like the equation of a circle, so you can tell me that the center is at -5, +1, and the radius is the square root of 36, which is 6. And that is it for lesson 10. So on to lesson 11. Lesson 11, I'm not going to lie, is kind of tricky. It is the locus definition of a parabola. So first things first, remember parabolas are the graphs of quadratics, so they look like U's. And it involves 2 special things. One of them is a point. It is known as the focus. The focus is a special fixed point that any point on the parabola is the same distance to the focus as it is to the directrix, which is a fixed line. It's always going to be a horizontal line. So real quick review, any horizontal line, to name any horizontal line's equation, so let's take like this one up here. Let's say this went through the point, I don't know, 0, 3, like that's at 3. So this would be the line y equals 3. It's always y equals some number. So horizontal lines always look like y equals whatever number they pass through on the y-axis. So if it's going through up at +10, it would be the line y equals 10. If it's going through down here, I don't know, we'll say this is at -5. This would be the line y equals -5. So it's a quick review. That's how you name horizontal lines. So anyways, back to focus and directrix. So what is special about these 2 things is that if you chose any point on your parabola, so if you look at this one in exercise 1, if I chose any point on here, the distance that that point is to the focus will be the same as it is to the directrix. Now the only problem is, if you are finding the distance from any point to the directrix, that's going to be pretty easy because you can just count how many lines on your graph. It is a way from that line. But if you're going to a special point, which is the focus, you can't always just count the lines, because if it is not like a horizontal distance or a vertical distance, for example, look at the point 4, 5. If you were to find the distance from 4, 5 to this focus, it is not a horizontal or vertical line, so you cannot just count the boxes that it goes through. You're going to have to use what we learned last year in geometry, which is the distance formula. Don't forget, though, the distance formula comes from the Pythagorean theorem, so you could always turn this into a right triangle, and then you could count the two legs of the right triangle and do a squared plus b squared equals c squared. But anyway, so let's go on and do this exercise, and then hopefully you'll get a better understanding of what the directrix and the focus are. So this question, they give us this parabola and they tell us his equation. They did that on purpose because you're going to actually see how to come up with this equation if they give you the directrix and the focus, which they did. They told us that the focus is the point 0, 2, which is right here. And then they told us the directrix is the x-axis. Well, the x-axis, in case you didn't know this, has an equation of y equals 0. Okay, the x-axis is a horizontal line going through 0, so it has an equation of y equals 0. Okay, so the first part says, how far is the turning point 0, 1? So we're looking at, I'll do it in red, so it's a different color than the focus and the directrix. How far away is that point from the focus and from the directrix? Well, this is a nice point they asked you to work with because it is vertically right below the focus, so I can just count how far away it is. So 0, 1 is 1 unit away from the focus. Well, it's also 1 unit if you count down to the directrix, which was, I'll trace this in blue, this line is your directrix. It is also only 1 unit away from the directrix. So it's 1 there and 1 there. So 0, 1 is 1 unit from focus and 1 unit from the directrix. It asks us to also look at the point 2, 2. Well, 2, 2 is another nice point. I'll use green this time. 2, 2 is right here. From the focus, it's a horizontal line, so I can just count how far away that is. That's 2 units away. And then down to the directrix, oh, look at that. It's also 2 units away. So the point 2, 2 is 2 units away from both. So that is the special property of the focus and the directrix. Any point on the parabola will be the same distance that it is to the focus as it is the directrix, or vice versa. Now notice they're not the same distances. 0, 1 is only 1 away from both, 2, 2 is 2 away from both, and you're about to see that 4, 5 is not going to be 1 or 2 away from both, but it will be the same. So for example, if 4, 5 was, I don't know, 10 units to the focus, it'll be 10 units to the directrix. So once you find the distance to one, you know the distance to the other. So this one actually asks us to use the point 4, 5, and it says, find the distance that 4, 5 is from the focus and the directrix. Well, you can count. If you look at 4, 5, you can count how far away it is from the directrix because you can just go straight down until you hit that line and just count those boxes because it's a vertical line. 1, 2, 3, 4. It's a distance of 5. Well, I better hope that I get a distance of 5 when I do my distance formula from that point to the focus. So in case you forgot the distance formula, again, you can turn it into a right triangle and do a squared plus b squared equals c squared. But the distance formula looks like this. It's x minus x1, so those are your two x coordinates, plus y minus y1 squared. I forgot the word squared in there. So you're going to plug in your two x values, your two y values, subtract them, square them, add them together, and then square root it. So the two x's that we are finding the distance between are 0 and 4. And it doesn't matter who you add or subtract or who goes first, because you're going to end up squaring it. So even if you get a negative, if you reverse the order of subtraction, when you square it, it'll be positive anyway. So if I do 4 minus 0 squared plus the y's, so now I should go in the same order. So the y that went with 4 was 5. And the y that went with my focus is 2. So now I'm just going to do some algebra in my head. So 4 minus 0 is 4. I'm going to square it. 5 minus 2 is 3. 4 squared is 16 plus 9 is 25. The square root of 25 is 5. Oh, look at that. I got a distance of 5 to both the focus and the directrix, which we know should have happened. You would then repeat the same thing for the 0.610, but let's just see, it's going to be 10 units away, so you're going to get 10 if you do the distance formula there. So now this is why you need to know this. In the future, they're not going to give you this equation. They are just going to give you the focus and the directrix, and you're going to have to come up with this equation, and you have to know how to do that. So what you need to realize, I'll go back up here and write this out. So this was the distance to the focus, and this was the distance we just counted to the directrix. It was 5. So what you need to realize is that the distance to each is the same, which means I can set them equal because they are the same. They are equal, okay? So I am going to pick any point, x, y. This is what you're going to do for these types of questions. Pick any point. Well, because it's any point, we're going to call it just x, y. We know that the directrix is the line y equals 0. Well, you're going to be y units away from the line y equals 0. For example, just to have that make a little more sense, look at the point 2, 2. 2, 2 is 2 from the y equals 0 line because the y coordinate is 2. The point 4, 5, for example, the y coordinate was 5. It's 5 from the line y equals 0. So the distance is going to be y for the directrix. It's going to be y away. Whatever y is, that's how far it'll be from the directrix. Now the distance for the focus is going to be, you're going to plug in our point. We're going to the focus, which is 0, 2 again. So if you want to make a little note to yourself, the focus was at 0, 2, and our point that we're finding the distance between is x, y. So that's known as x minus 0 squared plus y minus 2 squared. Well, I can set these two distances equal because I know they're going to be the same. So you're going to set those equal. So I'm going to set y equal to the square root. I'm going to write x minus 0 as just x, and then y minus 2 squared has to stay y minus 2. And now I'm going to solve for y. I want to get y alone because that's how equations of parabolas look. And equations of lines, equations of any function, y is alone. So to do that, to get rid of this radical, I'm going to square both sides. If I square both sides, that radical will cancel with that squared. So I get y squared equals, the radical is now gone. And if I square this out, remember y minus 2 squared is really y minus 2 times y minus 2. So you're going to rainbow that out. So that would be y squared minus 4y plus 4. Now, this will always happen. You're going to get y alone, and when you start to do that, when you move this y squared over to the other side, it's going to cancel out the other y squared. That will always happen. The y squareds will go away. Now let's get y alone. So you want to move him to the other side so he's all alone. So I'm going to get positive 4y equals x squared plus 4. And then to get y alone, I'm going to divide everything by 4. So if I divide this guy by 4 and this guy by 4, remember there's an imaginary 1 there. That can't be reduced anymore, so I'm going to leave it as 1/4 x squared. And 4 divided by 4 is 1. Oh, look at that. We got what they wanted us to get. So we knew what the answer should be. In the future, you won't. You won't know the equation. You're going to have to come up with this by doing what we just did. So let's do one more example. This time, they told us, they gave us a parabola whose focus is at 0, 7. So I'm going to plot, it says sketch, so it doesn't have to be perfect. 0, 7, I'll say it's right here. And the directrix is the line y equals 3. So if this is up at 7, I'll call this point right here at 3. Well, it's going to be a horizontal line through 3. Whoops, that didn't quite go through 3. So what you now know is that your parabola has to, your turning point has to be between here, and you can never go past your directrix. So it has to be a right side up parabola. Whoops, that is terrible. But basically, I should have drawn this so that it's in between these 2 points, because remember, it's going to be equidistant. So that doesn't really look it, huh? It should have been at 5. This looks more like 5.5, but you get the idea. So now we're going to come up with the equation. Well, remember, you're going to pick any point. I'll pick this one. I don't know what it is. It's xy. The distance that this point is to this line is going to be the same. So this distance will be the same as whatever this distance is. So I'm going to set up those 2 distances using my distance formula and then using my knowledge of how far away this is. Well, if this is the line y equals 3, this point is y minus 3 away from this line. So take, for example, I don't know, this was 8. It would be 5 away from this line. 8 minus 5, or 8 minus 3 is 5. So therefore, this distance is y minus 3. That's that distance. This distance, so this is the point 0, 7. So you're going to set up the distance formula between that point and xy. So that distance is the square root. It's always going to look like this. X minus whatever the x coordinate of the focus is, which is 0, plus y minus whatever the y coordinate is, it's 7. And now you're going to set these 2 distances equal. So I'm going to set y minus 3 equal to the square root. X minus 0 is x squared plus y minus 7 squared. I'm going to square both sides. Now be careful. Watch what I do. You got to put parentheses around this because you got to square the whole thing. And then you're going to square that whole side. Well, when you square this whole thing, that really means y minus 3 times y minus 3, which is y squared minus 6y plus 9. And then this side turns out to be x squared. The square root is gone because that squared got rid of it. If I square this out, it's going to be y squared minus 14y plus 49. Now again, the y squareds will cancel out. That will always happen because if you start to move the y's to one side, the y squareds will go away. Now let's bring this negative 14y over to this negative 6y by adding it over. And then we're going to subtract this 9 over to this side because we want to get y all alone. So this is 8y equals x squared plus 40. And then the last step is to divide everything by 8. And you're going to simplify if possible. So the first fraction can't be simplified anymore. That's really 1/8 x squared. And then 40 divided by 8 is 5. So that is the equation of that parabola. And again, you should graph that on your calculator to check that it is something like this and that it looks like it's the same distance from 0, 7 and the line y equals 3. And that is it for lesson 11 and unit 6 in general.